A school committee consists of 3 upper 6 students, 5 lower 6 students and 6 fifth formers, is to be chosen from a group of 24 candidates comprising of 6 upper 6th, 10 lower 6th and 8 fifth formers. How many different committees can be selected? So we need to consider each of the things separately, i.e. we need to consider upper 6th, lower 6th and fifth formers each separately. In the upper 6th there were 6 to choose from, and we needed to choose 3, so that's 6C 3 ways. The lower 6th there were 10 to choose from, and we needed to choose 5, so it's 10C 5. And for the fifth formers there was 6 we need to choose from 8, so that's 8C 6 ways. These group selections are independent, so the total number of possible committees that we can have is going to be 6C3 times 10C5 times 8C6. Now we can work that out on our calculator using the calculate button and get 141,120. Or we can proceed and break down the calculation using NCR is equal to n factorial over n minus r factorial times r factorial. So that becomes 6 factorial over 6 minus 3 factorial times 3 factorial times 10 factorial divided by 10 minus 5 all factorial times 5 factorial times 8 over 8 minus 6 factorial times 6 factorial. Writing that out again, and then on the top we're going to have 6 factorial, 6 minus 3, it gives me 3 factorial, and then the same for the second one, 10 factorial, 5 factorial divided by 5 factorial divided by 5 factorial, and then 8 factorial divided by 2 factorial times 6 factorial. Now it gives me on the top 6 times 5 times 4. Why? Because 3 factorial will cancel out the 3 times 2 times 1. Still got one remaining 3 factorial, so that's going to be 3 times 2 times 1. On the top again we're going to get doing a similar idea, 10 times 9 times 8 times 5 times 6, because the rest is cancelled out by one of these 5 factorials. On the bottom we've still got 5 times 4 times 3 times 2 times 1. And then in the last case we're going to have 8 times 7, and the 6 factorial cancels everything else out, and then we've got 2 times 1. Then we can do a little bit of cancelling. 3 and the 2 and the 4, that gives me 20, 2 times 5 times 2 over 1. And then on this one we can do the 5 and the 10, the 4 and the 8, the 3 and the 9, the 2 and the 3. So on the top we've got 1 on the bottom, so we've got 2 times 3 times 2 times 7 times 3. This gives me 252. And the last one we've got 2 and the 8, 4, and then 4 times 7 gives me 28. If we do 20 times 252 times 28, again we're going to get the same answer as 141,120 committees. So got 2 ways of doing it. Obviously the calculator way is quicker, but this maybe gives you a little bit of understanding of the arithmetic involved. Okay, this has been a video to show you how to use combinations to select a committee. I hope you've understood, and I thank you very much for watching.